This is Unit 4, Assignment 6, the review, the answer key. You feel free to fast forward to whatever questions you need some help on. The directions I've highlighted there, if you want a resource for these first three questions, you should be using factoring to find Part B, which is the X-Intercepts. Assignments 1 and 2 would be good resources if you are unsure maybe how to start. So in question 1, the first piece is, does this graph open up or down? It's going to open up. Reminder, doesn't mean the graph moves up, it's just that it opens up. It's the direction it faces. The reason we know it opens up is because the x squared is positive. Now to find the x-intercepts, we're going to use factoring. To find the x-intercepts, we have to put 0 in for y. We put 0 in for y. And then for the factoring piece, this one has just a plain x squared. So we can shortcut this one. I'm just going to make a little note here. So we want to find two numbers that multiply to give us -5, add to give us 4. The only two numbers we can multiply together to get 5 are 5 and 1. And then to get -5, one of those two has to be negative. To get +4, we know we have to make the 1 negative. We put our two numbers we found in with our x's. And then we do have to finish off and solve. 5 and -1 are not my x-intercepts. -5 and +1 are my x-intercepts. So we'd have -5, 0, and we would have 1, 0. The axis of symmetry, one of the fastest ways to find that is to just add your x-intercepts together and divide by 2. So we have -4 divided by 2. Axis of symmetry is at x equals -2. Do not forget the x equals part. It is a line. So we do have to have the x equals. I'm going to go ahead and just graph the intercepts at 1 and -5, and I'm going to go ahead and graph my axis of symmetry at x equals -2. Now, if the axis of symmetry does not split your graph in half, you do not have the right value. It should split your graph in half. Now, for the vertex, we already know the x value. To find the y value, I have to put the x back into the original equation for x. So we're going to have -2 squared plus 4 times -2 and then -5. So if we go ahead, you can throw that right in your calculator. And we end up with y equals -9. There's the other part to my vertex. If I want to go ahead and graph that, I can. Then the y-intercept, we put 0 in for x. I know a lot of you don't show work for this. The y-intercept is just that constant value, or our c value. Please make sure you graph this and then reflect it over. The domain is always all real numbers. The range deals with y. Our graph opens up, so we're greater than or equal to, and it's the y value at the vertex. Question number 2 is going to be the same process. This graph's going to open down because the number in front of our x squared is negative. So our graph should look like this. If it doesn't, when you graph, you know you did something wrong. You need to go back and check your intercepts or your vertex. All right, so this one, again, we're going to use factoring. To find x-intercepts, we put 0 in for y. Now, when you're factoring, always try GCF first. Every term can be divided by -3. Once I do that, now I'm left with a plain x squared. Now I can shortcut. Multiply to get 3, add to get 4. The only things I can multiply to get 3 are 1 and 3. The negative 3 just comes along for the ride. Now I have to actually find those intercepts. I have to set each factor equal to 0 and solve. So my x-intercepts are -3 and -1. If you want to go ahead and graph those, you can. Axis of symmetry, I know for some of you, you're like, Ms. Golly, can I just look at it and tell where the middle is? You sure can. If you need to, add the x-intercepts together and divide by 2. Make sure you do the addition first before you divide. Don't forget the x equals part. Axis of symmetry gives us the x value at the vertex, and then we have to take that x and put it back into the original equation to find the y. And again, that's something, guys, enter that right into your calculator, parentheses and all. Don't leave out any parentheses. And our y value is 3. -2, 1, 2, 3. There's my vertex. Y-intercept, if you want to show the work of putting 0 in for x, you can. If you want to go through the work to put that in your calculator, you can. These terms just all equal 0. We're left with -9. Make sure you graph the y-intercept at -9 and then reflect it over that axis of symmetry. Domain, all real numbers. The range, we're opening down, so y is less than or equal to. The y value at the vertex is 3. All right, our third and final question with factoring. This one will open up our x squared coefficients positive. Now to find those x-intercepts, we put 0 in for y, and we want to use factoring. You can always try GCF first anytime you don't have a plain x squared for the shortcut. In this case, there's nothing common I could divide all 3 of those by without creating some decimal or fractions. So I do have to do the method of grouping with either the parentheses or the boxes, whichever you like. So we start by taking the first term times the third term. So we're going to multiply to get -24. We're going to add to get -5. If you need to, you can use a multiplication table on your test. We're going to have -8 and 3. Now the piece people are forgetting is now I have to actually split apart that -5x using those 2 numbers I found. These 2 numbers do not just go right into the parentheses like the shortcut method. We have to actually do this out with either grouping with parentheses or the boxes. So if I use the parentheses, I'm going to group the first 2 and the last 2. If I use the boxes, I'm going to sketch that over to the side here. We have 2x squared minus 8x plus 3x minus 12. So either setup will work. We'll get the same thing. I will show both. I'm going to start with the parentheses. First set of parentheses, they can both be divided by 2 and an x. I'm left with x minus 4. Second set, I can divide both by 3. And again, I'm left with x minus 4. The 2 sets of parentheses match. That's what we need. That's now my GCF. I'm left with 2x plus 3. And then my GCF was x plus 4. For the boxes, I'm going to start the first row. 2 and -8 can both be divided by 2 and an x. 3 and -12 can both be divided by 3. 2x squared and 3x, just an x. We have a double negative in that last column, so we're going to have a -4. There's our 2x plus 3 and our x minus 4. Then you still do have to actually find the x-intercepts And I'm out of space here. We have to divide by 2. And this is negative 1.5 is x. And then subtract 4. X equals negative 4. So negative 1.5 and negative 4. Oops, sorry, rewind. It's x minus 4. X minus 4, so we add 4. X is positive 4. There we go.
You want the door shut or? Gotcha.
All right. So now we have our x-intercepts. If you want to graph those, we've got positive 4 and negative 1.5. Axis of symmetry, again, if you want to try to figure out the middle by looking at it, or easiest way, add the intercepts together and divide by 2. Again, please keep in mind you need to do the addition first, then the division. So we get 1 1/4. You can leave it as a decimal if you'd like. So x equals 1.25. That's the x of my vertex. I have to then put it back into my original. And again, don't let this worry you that there is a decimal there. We're going to use our technology. Throw it in the calculator. That's what I'm going to do right now. And we end up with negative 15.125. That's okay. That's a nice terminating decimal. Don't round it. It looks good there. So my vertex point is at 1 1/4. Actually, I'll go ahead and draw on the axis of symmetry. 1 1/4, try to make that line closer to 1 than it is to 2. And then negative 15.125, it's not going to fit with our current scale, so I'm going to change. And since I have to fit 15, it's an odd number, I'm going to go by 3s. So each line on the y-axis is now worth 3. So negative 15, so negative 3, 6, 9, 12, 15. And then go just a little bit below it. Actually, let me change to red so you can see it better. There we go. And then the y-intercept. Again, it's up to you. If you want to show yourself putting all those zeros in for x, you can. Those terms are just 0. The y value is just our constant. So negative 12. Again, we're going by 3s on that y-axis. So there's negative 12. And I reflect that point over. The domain is all reals. The range, y is greater than or equal to, because the graph opens up. And it's greater than or equal to the y value at the vertex. Feel free to pause, rewind as you need to. All right, moving on, we're going to do the quadratic formula next. The quadratic formula will appear on your test. I just did not put it here. So feel free to take your notes out if you need to reference the quadratic formula, or you could even look it up on your computer or your phone, whatever you're using to watch this video. All right, we come across our up or down question. This graph will open up because our x squared is positive. You don't have to draw the picture. I'm just showing you what it's going to look like when we graph. All right, to find x-intercepts, 0 goes in for the y. And we're going to use the quadratic formula. So I'm going to pick out A, B, and C. Watch your signs. And then I like to find the discriminant first so I know how many intercepts I should have. All right, so the discriminant is b squared minus 4 times a times c. Again, it's something, just pop right in your calculator. And we come up with 44. Now, since the discriminant is positive, that tells us that we're going to have 2 solutions, and we're going to have 2 x-intercepts. So now since I know I'm going to have 2 solutions, I'm going to find them using the whole formula. So x equals, we have the opposite of b plus or minus the square root of the discriminant, all divided by 2 times a. I'm going to clean this up a little bit. The negative 4 becomes positive. Square root of 44, it doesn't work out pretty. So we're going to go ahead and just round to the nearest hundredths like we've been doing. So 6.63, all divided by 2. We should use approximate symbols because I did round that square root. So x is approximately 4 plus 6.63 divided by 2. X is approximately 4 minus 6.63 divided by 2. Please make sure you do the addition first, then divide by 2. Make sure you do the subtraction first, then divide by 2. So those are our x-intercepts. Then for the axis of symmetry, we have our handy little formula, the opposite of b, all over 2a. B in this case is -4. If you want to just go ahead and put 4, you can. If you need to show yourself the double negative, you can. So we get +4 divided by 2. Our x is 2. If you want to go ahead and start graphing some pieces, you can. 5.315, we'll go over 1, 2, 3, 4, 5, and then try to keep it to the left side of half the box, but I know the boxes are small, that's okay. And then -1.315. Axis of symmetry is at x equals 2. Always double check to make sure that line you draw actually does cut your graph in half. The 2 x-intercepts should be equidistant from that middle line. All right, so I've got the 2 for my vertex. That 2 has to go back into the original. So 2 squared minus 4 times 2 minus 7. We'll have y equals -11. So to graph my vertex, we need to change our scale. I'm just going to go ahead and go by 2s. There won't be anything nice to get us exactly 11 like we saw with the 15 earlier. So each line now on the y-axis is worth 2. So 2, 4, 6, 8, 10, so 11 will be right in between the 5th and 6th line. That would be for 10 and 12. Y-intercept, if you want to show yourself putting the zeros in, you can. The y-intercept is just your c value. Remember, your y-axis is going by 2s. 2, 4, 6, so 7 is going to be halfway. Reflect it over to the other side. Domain is all reals. Range, y is greater than or equal to the y value at the vertex. Question number 5, same process. This one will open up because the x squared is positive, so our graph should look like this. X-intercepts, I put 0 in for the y. And then I'm going to start by finding A, B, and C. I know the directions don't say it, but I like finding the discriminant first so I know how many solutions to expect. So we've got b squared minus 4 times a times c. You can put that right in your calculator. We're going to come up with a 0 there. So since there's a 0, that means we're just going to get one solution, which in turn means one x-intercept. So x equals the opposite of b plus or minus the square root of our discriminant, all divided by 2 times our a. So I'm going to clean this up a little bit. The negative 12 becomes positive 12. Square root of 0 is 0. 2 times 2 is 4. Now, I know we said earlier we're just going to get one solution, because if we add or subtract 0, that numerator is just going to stay at 12. So our x-intercept is just 3. These are going to be the ones that you should come to like the most, because if we only have one x-intercept, it doesn't have a mirror image. The only point on our graph that doesn't have a mirror image on the other side of the axis of symmetry is our vertex. If you want to go through the work and do the formula for the axis of symmetry and do the work for the vertex, you can if you ever need to double check yourself, or you can quickly go through those. Y-intercept, if you need to show yourself the zeros, you can. Otherwise, the y-intercept is always just our c value. 18 will not fit on my regular graph, so I'm going to have my y scale by 2. So y-intercept of 18 will be right up at the top, and then I go ahead and reflect that over to the other side. Domain is all reals. Range y, it opens up greater than or equal to the y value at the vertex, which is 0. As we're going through this, guys, remember you can pause to catch up or rewind at any point that you need to. If you need to re-see or rehear something, feel free to rewind. All right, the last one for the quadratic formula, question number 6. This one's going to open down because we have a negative in front of our x squared. Put 0 in for my y. My a is -3. My b is 6. My c is -4. I like finding the discriminant first. B squared minus 4 times a times c. I always find that first, so I know how many solutions to expect. And it's also part of the formula, so it's not extra work. So if I go through and do that work, this actually comes out to be -12. A negative discriminant, again, that's the value that's underneath our square root. Negative discriminant means no solution, which equals no x-intercepts. So by finding the discriminant first, I've saved myself a lot of work. The discriminant doesn't create more work, but in the case of question 6, it saves us the work of putting everything into the whole quadratic formula. Now, just because we have no x-intercepts doesn't mean we can't find the axis of symmetry. It just means that our graph isn't going to touch or cross the x-axis. So axis of symmetry, we're going to do the opposite of b, all divided by 2 times a. Make sure you do the division in the denominator first, or excuse me, do the multiplication in the denominator first before you divide. So axis of symmetry we can get, and we can also get the vertex. Put the value for the axis of symmetry into the original equation. Again, pause if you need to. If I'm going faster than what you can process or keep up with, pause as you need. So we have an axis of symmetry of 1. We have a vertex of 1, -1. You might be thinking, how do I get the rest of the graph? Well, we need to find all the pieces first. We need that axis of symmetry, or excuse me, the y-intercept. So 0, -4 for the y. I reflect it over, and now I have a nice looking graph. Domain all reals, range, y is less than or equal to, because we open down. The y value at the vertex is -1. All right, last but not least, moving on to our last page. I know this says questions 7 through 12. I misnumbered, so we're looking at 1 through 6. We're going to complete the square to solve, which gives us our x-intercepts. And then we're going to change our equation to vertex form to find vertex and axis of symmetry. All right, so the step-by-step process that I went through during the lesson, you might want to have your note sheet out for that, but if not, I'm going to go through the steps here. Step 1 is to move our constant, our c value, to the other side. So I'm going to subtract 15 from both sides. X squared minus 8x equals negative 15. Now we need to find what we need to complete the square. So we take half of our b, or b divided by 2 if you prefer to see it that way. We take that value and we square it. Make sure you use parentheses in your calculator when you're squaring negative 4. All right, our next step says we need to add that square to both sides. We have to keep our equation balanced. So we have x squared minus 8x plus 16, and we have negative 15 plus 16. The next step says we need to write that trinomial as a binomial squared. We're always going to have x in there, and then half of b. And then negative 15 plus 16 is 1. From here, to solve, to undo the square, we square root both sides. So x minus 4 could equal positive 1. X minus 4 could equal negative 1. I did take the square root. The square root of 1 happens to be 1, or negative 1. Add 4 to both sides. X could be 5. Add 4 to both sides. X could be 3. So our x-intercepts would be 5, 0, and 3, 0. Now to get our vertex, it's pretty easy. We have x minus 4 squared. So if we go back to before we did the square root to solve, to get the vertex form that we worked with all last unit, we need to bring that 1 back to the other side. Now we have a minus 4 inside the parentheses is going to go right 4. A minus 1 outside goes down 1. Right 4 is positive, down 1 is negative. This is our vertex. Axis of symmetry is just x equals the x value at the vertex. So this is our axis of sim. All right, same exact process going into question 2. Move our c value, which is our constant, to the other side. So we're going to subtract 22. So x squared plus 10x is going to equal negative 22. Half of 10 is 5. We square 5 and we get 25. To make our square, we need to add 25 on that left side. To keep things balanced, we're going to add 25 on the right side. To get our binomial squared, we have our x, and then half of b is positive 5. And then on the right side, we get 3. To solve, to undo the square, we take the square root of both sides. Now in this case, square root of 3 doesn't work out fantastic, so we're going to approximate that to 1.73. Our x plus 5 is approximately negative 1.73. Subtract 5. X is approximately negative 3.27. Subtract 5. X is approximately negative 6.73. So these would be roughly the two x-intercepts if we were to sketch a graph. To get the vertex and axis of symmetry, we just rewind back to before we did the square root. Let's bring the 3 to the left side. Now we have vertex form. The plus 5 inside is going to go left 5. The minus 3 is going to go down 3. Left is negative, down is also negative. There's our vertex. Axis of symmetry, x equals the x value at the vertex. Moving on to number 3, same process as the first two. Let's go ahead and move our constant to the other side. Half of b, we take that half and we square it. There's the square we need to complete our square. So x squared plus 6x plus 9. That would give us a square if we drew it out with algebra tiles. And then we have negative 10 plus 9 over on the right side. We have to add 9 to both sides to keep it balanced. Then we have x plus half of b is 3, and we square it. And then over on the right side, we have negative 1. To undo the square, square root. But now here's where we're stuck. And if you need to verify in your calculator, you can. If we try to take the square root of a negative number, our calculator is going to tell us it's an error. It's going to say it's a non-real answer. We've talked about this many times. To take the square root means we're trying to find what number squared or what number times itself is going to equal negative 1. And the only way to get negative 1 would be to multiply a positive 1 times a negative 1. And that's not a squared value. It's two different signs. So at this point, we would have no solution. So no x-intercepts if we were to graph. Now we can still, though, find the vertex and axis of symmetry. We can add the 1 back over to the left side. So we have x plus 3 squared equals, not equals, x plus 3 squared plus 1. We have left 3, and we have up 1. So I'm going to go up here where there's more space. So my vertex, the left 3 is negative 3, up 1 is positive 1. Axis of symmetry is x equals negative 3. So even though we didn't have any x-intercepts, we can still find a vertex and axis of symmetry. No x-intercepts would just mean our graph would not touch or cross the x-axis is all it would mean. All right, number 4, same process. Start by adding our constant to the other side. So add 18 to both sides. Then we find half of b. And then we take that value and we square it. Negative 7.5 squared is 74.25, so 74.25. We need to add that square to both sides. So we're creating a square on the left side, but to keep things balanced, we also have to add it to the right side. Oh, wait, negative 7.5 squared is not 74.25. Sorry, guys, I got a bit ahead of myself. 7.5, negative 7.5 squared is 56.25. I got a step ahead of myself there. Sorry about that. So over on the left, we're going to have x. And then half of b is negative 7.5. We square it. And then over on the right side, there's the 74.25. I just got a little bit ahead of myself, guys. So then from here to undo the square, we take the square root of both sides. So we have x minus 7.5. The square root of 74.25, it doesn't work out perfect. We get approximately 8.62. X minus 7.5 is approximately negative 8.62. Add 7.5 to both sides. X is approximately 16.12. Add 7.5 for our second case. X is approximately negative 1.12. So if we were to graph, these would be our approximate x-intercepts for our sketch. Then to get the vertex and axis of symmetry, we go back to before we took the square root. bring our 74 1/4 back over to the left side. And so what we have is we have x minus 7.5 squared minus 74.25. So on the inside of the parentheses is a minus 7.5. So it's going to be to the right 7.5, which is positive. Then down 74.25, which is negative. Axis of symmetry is x equals positive 7.5. All right, getting closer to our last question here. We're on our second to last one, number 5. Same process. So we're going to add 8 to both sides. That's our constant. We're going to move it out of the way so we can make our square on the left. To make our square, we find half of b, and then we square that value. So negative 3.5 squared is 12 1/4. So we take that square and we add it to the left side to complete our square, and then we also have to add it to the right side to keep things balanced. On the left side, we're going to write our binomial squared, so x minus half of b, and we square it. And then over on the right side, we add those two together and get 20.25. To undo the square, we square root both sides. So x minus 3.5 will equal positive 4.5. X minus 3.5 will equal negative 4.5. Add our 3.5 to both sides, we get x equals 8. Again, add 3.5 to both sides, we get x equals negative 1. So these would be our x-intercepts if we were to graph. To get vertex and axis of symmetry, we go back to before we took the square root to find those x-intercepts. Move the constant back over to the left side. Now we go to the right, 3.5. We go down 20 1/4. So the vertex, we're going right, so it's positive. Down is negative. Axis of symmetry is always x equals the same x value at the vertex. All right, last question for this review. Same process as we did on those top 5 so far. Move your c, aka your constant, over to the other side. We find half of our b value, and then we square it. Negative 1 squared is just 1. We take the square and we add it to both sides. We make our square over on the left. X, in this case, will be minus 1. That's half of b. We square. Over on the right side, negative 4 plus 1 is negative 3. To solve, we take the square root to undo the square. We run into the same problem as we did in question number 3. I cannot find the square root of a negative. It's not a real solution. So it's no solution. We're going to have no x-intercepts. Now, just because I don't have x-intercepts doesn't mean that I don't have a graph. I can still go back to before I took the square root. I can move the constant over to the left, and I can get vertex form. This graph is going to go to the right 1 and up 3. Axis of symmetry is always x equals, and then it's the x value at the vertex. If you need to, feel free to rewind back to any questions. If there's ones I went too fast through, feel free to pause, rewind. If you need to ask me questions, feel free to stop in and see me.